All right, welcome to class, everybody. Our lesson today, section 7.4, is, in my opinion, one of the easiest sections. So we're going to be talking about how to add and subtract radicals. So remember, radicals is just another word for roots, like square roots or cube roots or fourth roots or things like that. And basically, the way that you add and subtract radicals is kind of like you add and subtract like terms. So when I see a problem like 6 times the square root of 2 plus 3 times the square root of 2, kind of the way you want to think about it is similar to like if you had 6x plus 3x. So you basically just combine the terms that are the same or like that have the same type of radicals. So if I have 6 square roots of 2 plus 3 square roots of 2, how many square roots of 2 do I have? 9. And so the answer is just 9 square root of 2. And if you were subtracting, you would do the same type of thing. Now, the main thing you need to be aware of when you're adding these is that the roots have to match exactly. So your textbook calls them similar radicals. So like in this first line, 4 square roots of 5 and 7 square roots of 5 are similar radicals because the square root part is the same. They both have a 5 on the inside of the root and they're both square roots. Same thing with this one. You could have similar radicals where you have 2 cube roots of the same thing. However, these two in this last example would not be similar radicals because this one is the square root of 3 versus this one is the cube root of 3. So the type of root has to match and the stuff on the inside has to match. If they were both cube roots of 3, that would work. Or if they were both square roots of 3, that would work. But since they're different types of roots, they would not be considered similar radicals. So you wouldn't be able to combine those like terms. So this is the basic idea of our entire lesson, which is basically if you have similar radicals, you can add or subtract them together. And it doesn't matter whether they're square roots or cube roots or whatever. So in this case, what do you guys think the answer would be? Perfect. Yep. So it'd be -3 actually cube root of 4 because this was a cube root. But basically I say I have 4 of these minus 7 of them. That gives me -3 of them. Now, some of the problems on your homework are a little bit more complicated than this. So I want to go through some examples. I'm going to start with question 4, if you guys want to follow along with me. Okay, so on this one, we have 3 different terms. We have 5 times the square root of 96, -6 times the square root of 216, and +2 times the square root of 150. And since none of the roots match each other, like they're all square roots, but they're square roots of different things, I can't combine them until I simplify them. So it turns out when I simplify these roots using what we did yesterday, then it will make it so that I'll be able to combine like terms. So to do that, I'll start off by simplifying the first one. And when I factor out 96, 96 can be divided by 3, which gives 32. 32 can be factored into 4 times 8. 4 is 2 times 2. 8 is 2 times 4, and 4 can be factored into 2 times 2. So 5 times the square root of 96 can be rewritten as 5 times the square root of 5 2's multiplied together times 3, because those are the prime factors of 96. Everybody good with that? Okay, so we can simplify this because if you take the square root of something that's squared, the square and the square root cancel each other out. So if I do 5 times the square root of 2 squared, that will just be 2. Then times the square root of another 2 squared will give me another 2. And then the 2 and the 3 don't have any other 2's or 3's that you could pair them with to make a square. And so you'll just leave those inside of the root and you'll get the square root of 6. Then you can simplify the stuff outside because 5 times 2 is 20, times 2 is 40. So this will simplify to 40 square root of 6. So that's kind of a review of what we did yesterday. Do you guys have any questions on that? The 40? That came from 5 times 2 times 2. Because 5, oh no, it should be 20. Yes. Thank you for catching that. Yes, it should be 20. Yeah. Okay, so that's the first term. Then I want to simplify this term as well. So 216 is an even number, so I can divide by 2, which leaves me with 108. That's an even number, so I can divide by 2, which leaves me with 54. 54 is 6 times 9, and 6 factors into 2 times 3. 9 factors into 3 times 3. So -6 square root of 216 can be rewritten as -6 times the square root of 3 2's times 3 3's. And when I take the square root of that, the square root of 2 squared will be 2. So I'll have -6 times 2. Then the square root of 3 squared is 3. And this 2 and this 3 didn't have any pairs that they were squared with. So those will stay inside of the square root, and that will be the square root of 6. Then I can simplify this because -6 times 2 is -12. -12 times 3 will give me -36. So this is -36 square roots of 6. And this is good because our roots are matching now. So we're not quite done simplifying because I still need to do that last term. But because I have square roots of 6 in both of my terms, that means I'm going to be able to combine them. So now to do my last one, I need to factor out 150. So 150 is 15 times 10. 15 is 3 times 5. 10 is 2 times 5. So 2 times the square root of 150 equals 2 times the square root of 2 times 3 times 5 times 5. And when I look inside of that square root, there's only one number that's squared, and that's the 5. So I'll take the square root of 5 squared, which is just 5. So I'll have 2 times that 5. And then again, the 2 and the 3 don't have any pairs with them, so they can't be square rooted. So you leave that inside the square root, and you end up with 10 square roots of 6. So when I write all of these radicals in simplified form, what I get is 20 square roots of 6 minus 36 square roots of 6 plus 10 square roots of 6. Well, if I have 20 of them and I subtract 36, that's -16. -16 plus 10 will give me -6. So my answer will be -6 square roots of 6, and that's my answer. So you'll have several problems on your homework where you'll need to simplify them first before you'll be able to add them together. But once you get them into simplified form, you should be able to add them together. I think there's one problem as well where you have to, like, you'll have the same. Let me see actually if I can find it. Okay. Maybe I don't have it on mine. Oh, like this one. Yeah, so like on this one, like these roots already match. So you could just say, well, if I have 3 of them, and I subtract 6 of them, I'd have -3. But this answer, so like your answer would be -3 cube root of 54. But this answer can actually be simplified more. So you have to make sure your answers are in fully simplified form. Otherwise the answer won't, or the homework system won't accept it. So that's on question 13. It might show up on other questions as well, but basically just make sure you simplify everything in your calculation and make sure the answer is simplified. The other example I wanted to go over is question 5, because this one involves variables. So just like our last example, you would want to get it into factored form and simplify it. So if I take a 96, that's divisible by 3, which gives me 32. 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. So that first term can be rewritten as 7x squared times the square root of 5 2's multiplied together times a 3 times 6 y's. So since I'm doing the square root, I look at it and I say, okay, well, if I take the square root of 2 squared, that's 2. So I'm going to have 7 times 2. Then I'll also have this another 2 because the square root of 2 squared is 2. And then I'll have my x squared. Then when I take the square root of y squared and y squared and y squared, oh, I think I actually wrote too many y's, sorry. I should only have 6. So when I take the square root of each of those y squareds, I end up with 3 y's, which is going to be y cubed. And then the stuff that's left inside of the square root is 2 times 3, because those ones didn't have any pairs. So I'd have the square root of 6 there. And that could be simplified to be 28x squared, y cubed, square root of 6, because 7 times 2 times 2 is 28. So that would be the first term. And then for the second term, I have negative 5y cubed, and 54 factors into 6 times 9, 6 factors into 2 times 3, 9 factors into 3 times 3. So I'll have the square root of 2 times 3, 3 times, and then I'll have 4 x's. And when I square root that, the square root of 3 squared is 3. So I'll get negative 5 times 3. Then I have the y cubed. Then I also have 2 x's, because when I square root x squared and another x squared, I'll get 2 x's. So I'll have x squared like that. And then I'm left with the square root of 6, because the 2 and the 3 still stay in there. And so this is going to equal negative 15 x squared y cubed square root of 6. So when I write that out, and I have my first simplified term, which is 28x squared y cubed square root of 6 minus 15x squared y cubed square root of 6. When I'm combining these, I need to first check and make sure they're like terms. So in order for them to be like terms, all of their roots have to match and all of their variables have to match. So the fact that I have an x squared and an x squared and a y cubed and a y cubed and a square root of 6 and a square root of 6, the fact that all of that stuff matches in both of them means that I can combine the like terms. So I'll say, well, I have 28 of all of that stuff minus 15 of all of that stuff, which 28 minus 15 is 13, I think. And so this would equal 13 x squared y cubed square root of 6. But all of it has to match. So like if this was just an x and this was an x squared, they wouldn't be like terms and you wouldn't be able to combine them, because like all of the variables have to match and all of the roots have to match to be able to combine like terms. Yeah. No, because it's kind of like the way that I would think about this is almost as if I were doing like 28x squared y cubed z minus 15x squared y cubed z. Like I almost kind of just think about these roots as being like a variable. And when we combine like terms, you don't do anything with the variables, you just make sure they're the same. Yeah, good question. Any other questions? Yeah. You would just leave it like this. I think in this lesson, they're going to design all the questions so that you can combine them. So I don't think it will really come up in this homework, but you would just leave, like if this was an X, I don't know, what was that comment? It's not 2y cubed. No, I'm not sure where you got the 2 from. Whoever put that in the chat. What was your question again? I forgot. I was in the middle of answering it. Oh yeah, if this one was an X and if this one was a X squared, then you would just leave it like that. I mean, I guess you could maybe factor out the stuff they have in common if you wanted to get it into factor form, but it would probably be just as simple to leave it like that. Yeah. Okay, in the chat, it said y cubed plus y cubed. Yeah, so we're not adding y cubes together. We're adding, so in the chat, they asked like why you don't go like y cubed plus y cubed equals 2y cubed. We're not adding y cubes together. We're adding x squared y cubed square roots of 6 together, because all of that stuff is multiplied together. So we're adding that stuff to itself, if that makes sense. So you don't do it term by term, because this entire thing is a term. Like the blue stuff is all a single term. The red stuff is all of a term. Yeah. All right. I'm not going to go through this example, but on question 6 and on other questions, you may have like fourth roots or cube roots instead of square roots. The process is still the same though. You just simplify all of the roots and then you add together the like terms. You'll also have a couple questions with fractions. So the main thing with these is just remember that when you add and subtract fractions, you have to have common denominators. In this case, we already have common denominators. So you would just simplify the roots and you'd say, well, the square root of 27 can be factored into 3 times 9, which is 3 times 3. So this would be the square root of 3 3s multiplied together. And the square root of 3 squared is just going to be 3. So this can be simplified to 3 square roots of 3, because you have 1 3 left over that didn't have a pair when you square rooted it. So you could rewrite the problem as the square root of 3 fifths minus 3 square roots of 3 fifths. And since the two fractions already have common denominators, then you can just go ahead and subtract the tops. And the square root of 3 minus 3 square roots of 3 is going to be negative 2 square roots of 3. And that will all be over the common denominator 5. So again, basically the same process. You just have to make sure you have common denominators to add the fractions. You also have one question on question 10, where you have a square root that's in the top, but then you also have a square root that covers the top and the bottom of the fraction. So the way you would want to solve this one is remembering our division rule, which says that if you take the square root of things that are divided, you can take the square root of each of them individually. So you'd think about this as the square root of 32 over the square root of 9 minus the square root of 50 over 3. And that actually makes it so you have common denominators as well, because the square root of 32 over the square root of 9 could be rewritten as the square root of 32 over 3, because this simplifies to 3. So you'd get the square root of 32 minus the square root of 50 over 3. And then when you simplify these two, so I'm not going to finish this problem, but if you simplified these two, they would probably end up having matching radicals, and then you could combine their terms. So that's the basic idea for this lesson. How are you guys feeling about it? Can we do a check-in, scale 1 to 5? Okay, awesome. Then I'll let you go ahead and start working on your homework. And if you have any questions, let me know.